Hello friends, I am Chandan. This is my handwritten notes. You can download it from the description. This video is only applicable only for mechanical engineering student. Otherwise, you can go to another video. So here our topic is that difference between free expansion and isothermal process. Isothermal process. Okay, so let's try to understand the difference between free expansion and isothermal process. If you if you draw this temperature in temperature axis in free expansion, basically suppose this is the initial state and this is the final state here. If you focus on the free expansion, the temperature is gradually decreasing from from initial state and to this point, and after that the temperature is increases. But in isothermal process, when you focus on the isothermal process, suppose this is the initial state and this is the final state, and there is a straight line. That means in the whole process the temperature that is equal to constant. So this is the difference between isothermal process and free expansion process. So here in free expansion the temperature is not constant throughout the process, but in isothermal process the temperature is constant in throughout the process. Okay, so what is the conclusion between free expansion and isothermal process? Here this is the conclusion. So here in case of free expansion, initial and final temperature are same, but the intermediate temperature are not same. Okay, now the second conclusion is that in free expansion, when gas expand initially the temperature will decrease, but finally due to no friction temperature again increases. Okay, so here there is no friction, so that is why temperature decrease, and after that there is friction is there, so that is why the temperature increases. Okay, now in third conclusion, that is in case of isothermal process temperature remain constant throughout the process. Okay, we know that in isothermal process the temperature is constant throughout the process. Okay, so this is all about the difference between isothermal process and free expansion process. Okay, now there is another question. Just understand this question, read the question and understand the question. Okay, a ideal gas at 20 bar and 40 degrees Celsius is contained in small cylinder having volume of 15 centimeter cube. This cylinder is placed in a large container having volume of 1500 centimeter cube. The large container is perfectly evacuated and insulated by an appropriate means. The gas is allowed to expand freely and fill the large container. Okay, the pressure at equilibrium condition is, you have to find what is the pressure when it is in equilibrium condition. So understand this question. When you read this question, you can see that it must be a free expansion process, because here there is a small cylinder which have volume 15 centimeter cube, and the pressure that is 20 bar, and the outside cylinder that is have 1500 centimeter cube, and this is totally evacuated, perfectly evacuated. So if it is perfectly evacuated or insulated, that means it is a pre-expansion process. Now the pressure and volume is also given. Just the pressure, the pressure at equilibrium condition. You have to find out when the pressure, what is the pressure at equilibrium condition. So this is basically here, this is our system here. There is a 20 bar pressure, and volume is small volume, that is equal to 15 centimeter cube, 15 centimeter cube. And the outside cylinder, this is the outside cylinder, that is basically vacuum, and the cylinder volume, that is 1500 centimeter cube. Okay, so just you have to find out the pressure P2. So you know the the equation, that is P1 V1, that is to P2 V2. So initial pressure is given, that is 20 bar, and volume 15 centimeter cube. So 20 into 15, and final pressure, suppose this is P2, consider this is a P2, and volume, that is 1500. From here you can get this data 0.2 bar. So this is the answer. Just simple question. Just try to understand this question. Okay, so the answer will be 0.2 bar. Okay. Okay, so this is my handwritten notes. You can download it from the description. Don't write anything, but just understand it. Just understand the question. That is very, very important. Okay, after that, prepare the question and all the notes by your own hands. Otherwise, it is difficult during your exam. Okay, now here from this from my notes here, from here you can see there is a open system is starts, open system starts. Okay, now so here in all the process, in above process, only there is a closed system is running, but here the open system is start. Okay, now suppose consider this is a system. Open system means there is a mass transfer is also there through the boundary, and energy is also transferred through the boundary. That is the meaning of open system. And suppose consider this is our system, and system, that means this is a control volume. CB means is the control volume, and here there is an inlet, and this is the outlet. Okay, so inlet is considered, this is 1 and this is 2, outlet is 2. Okay, now a small element, suppose there is a small element which is into the system, and the mass is also going out from the system. So this is basically an open system. So what is open system or flow work? You can say that flow work. So it is the work done required to entry the mass or exit the mass inside the control volume. So here open system means there is energy and mass transfer through the control volume, and if you want to find out the work, then it is known as flow work. Flow work. If you find out the work in open system, that is flow work. Okay, so what is the work required to entry the mass inside the control volume? This is the entry work. And what is the work required to exit the control volume? This is the exit work. This is basically known as flow work. Okay, now if you see that here, this is suppose consider this is a small element, this is a small element, and this area have A, and the pressure and volume, that is pressure is P1 and volume is P1, and the element is going from this to this, there is a distance, that is dx. So if you find out the work done, that is work done by P1 to entry mass inside control volume, that is equal to plus P into A into dx, P1 into A into dx. Why? P1 is the initial pressure, A is the area, dx is the distance, travel distance. Okay, so from here you can find out the work done, that is plus P1 into A into dx. So A into dx, basically this is dV. Okay, you can say that this is dV. So from here you can say that P1 into dV. So if you integrate this, integration del W, that is equal to integration P dV. So from here you can get that is equal to P1 V1 basically. So W entry by P1, that is equal to plus of P1 V1. So you can say that work done P1 to entry mass, that is equal to plus P1 V1. Or you can say that in the same way, you can say that work done by control volume to enter the mass, that is equal to minus of P1 V1. Basically here when there is a work, the element is going into the control volume, then control volume work is negative. Okay, the control volume work is negative, so here the control volume work is negative minus P1 V1, because by the work done by the control volume to enter the mass, here the work done P1 to enter the mass, that is why this is plus P1 V1, but here this is minus P1 V1. Okay, because the work done by the control volume. Okay, now work done in the same way, you can say that work done by the control volume to exit the mass. If the here that the mass is exit, so what is the work done? That is equal to plus of P2 V2. Okay, plus of P2 V2, this is given in the question. Just remember this data when the entry mass, when there is entry mass inside the control volume, the work done by the control volume will be minus P1 V1, and the work done by the control volume when there is exit mass, that is plus of P2 V2. Just remember these two data, because this is required for steady flow energy equation calculation. Just remember this data. Okay, in next lecture we'll understand what is steady flow energy equation and what is the derivation of steady flow energy equation. Now there is one question, just try to understand this question. Very easy question, just 2 minutes is required. Okay, so when a valve of an evacuated portal shown in the figure is open, atmospheric air rushed into the bottle. If atmospheric pressure is 1 bar and 0.6 meter cube of air measure at pressure at atmospheric condition enter into the bottle, find out the work done by atmosphere and work done by bottle and work done by air. So basically this diagram is given in the question. Okay, so here what is given, that is when a valve of an evacuated portal shown in figure is open, atmospheric air rushed into the bottle. So the first, this system is evacuated, and when you open the valve, the air is coming into the system because the outside pressure is large. Okay, the atmospheric pressure what is given, that is 1 bar and 0.6 meter cube of air measure at atmospheric condition enter into the volume. So what is the volume which is enter into the bottle, that is 0.6 meter cube. Okay, you have to find out that what is the work done by atmosphere and work done by bottle and work done by air. So just find this, just apply, remember this formula, that is this formula is applied. So work done by the control volume, so here this formula, work done by the control volume to entry mass, that is equal to minus P1 V1, and work done by control volume to exit mass, that is equal to P2 plus P2 V2. So this formula is applied in this question. So work done by atmosphere, that is work done by atmosphere, that is equal to P into V plus P into V, because by the atmosphere, so that is why plus pressure, that is 1 Pascal is given, this is 1 into 10 to the 5 Pascal and 0.6. So from here you can find that is plus of 60 kilojoule, and work done by the bottle, that is basically negative work. Okay, so that is negative work done by the control volume, this is basically work done by the control volume, that is equal to minus of 60 kilojoule. Okay, now if you find out the work done by air, the work done by the air, so this is equal to work done by air on atmosphere and plus work done by air on control volume or bottle. So here work done by air on atmosphere. Okay, so work done by air on atmosphere. So uh, here work done by atmosphere, that is the answer will be 60 kilojoule, plus 60 kilojoule. But if the work done by air on atmosphere, work done by air on atmosphere, so that is why the sign is changes, that is minus 60 kilojoule, minus 60. And here this sign is converted to this sign, this is because of plus 60 kilojoule. So minus 60 and plus 60, that is why this is equal to 0. Because understand that here the work done by air on control volume, so work done by bottle, that is plus 60 kilojoule, the work done in air on control volume, that is equal to plus 60 kilojoule. So minus 60 plus 60, the answer will be 0. So what is the answer of this question? That is 0. Okay, if you have any doubt, you can comment me. You can find the handwritten notes in the description. Like, share, subscribe my YouTube channel, and there is a Telegram link, you can join it. uh, Job update and video lecture are link are provided. My video link, lecture is provided in that link, in that Telegram group. You can join it, and like, share and subscribe my YouTube channel. Thank you.